I'm Scott Stoll. I've been involved with Flutter since September 2017. That would be 006, I think.
It's quite a long time.
Yeah, well, I'm dating myself. Anyway.
All right, I'm going to get off the stage and give a big round of applause for Scott for coming all the way here from Ohio.
All right. So, like I said, I'm going to take a little cue from Felix. How many of you have heard of rows and columns? Okay, I would say that's good, but the truth is I can't see anything with these lights, so I have no idea if you put your hands up. All right. This crowd is a bit more experienced than this talk is usually for. There are good things for you, but there are other parts that we're just going to blow right through in the interest of time. So before we get going, is that not the coolest picture of Jupiter you have ever seen on my not full screen? No. Oh yeah, that's right. F11. You have to be smarter than the computer to know how to use it, to be able to use it. Okay, is that not the coolest picture of Jupiter? All right. So first question, where is this going? Now that, well, no, it is an important question. How many times have you been sitting in a talk and you're sitting there going, what the heck are they doing? Where are they going with this? I don't even know what the point is. Okay, so let's take a look at where we're going. And this is where we're going to end up. Now I call this the tongue twister. And it'll make sense later, I hope. But here we go. A flex is flexible, but don't confuse the fact that it can be flexible with an actual flexible. A flex fit has nothing to do with the fit of the flex. Flexes don't fit. Flexibles do. The flex of a flexible determines the strength of a flexible, except when it doesn't. You can set the flex to 9 kajillion. If the flex fit is loose, it's not going to do squat. The flex fit of the fit determines if the flex of the flexible will be allowed to flex the flexible so that it fits better into the flex. And lastly, don't confuse the flex with the flex, or you're going to end up. Were you thinking something else? All right. Let's look at some terms. Now, this is the part we're going to blow through. Terms. The flex. It's a superclass of row and column. Next, the flexible can force its child to be bigger, doesn't have to. Flex, the strength of the flexible compared to other flexibles. Then the flex fit determines if it's going to have to fill the available space. The fit parameter takes a flex fit. So let's take a look at a doc comment for a moment, okay? And right here it says the expanded. It is a widget that expands the child of a row or column or a flex so that the child fills the available space. Okay, that's not what that button is supposed to do. I don't know where the laser went. Oh well. The available space. Now, let's define available space. Okay. Available is supposed to mean leftover. Okay? It's kind of like the food in the fridge, you know, when you get done with that pizza. But let's take a closer look at this, okay? A widget that expands the child of a row or column or flex so that the child fills the available space. Well, first of all, if you look at that carefully, the widget that expands the child of a row or a column, isn't the expanded the child of the row or column? Okay, that was a joke. You know, the child of the row or column is the expanded. So, anyhow, it says that it fills the available space. This, how do I put this? It's not exactly, yeah, that. Okay? It does not fill the available space. And this is where a lot of beginners and even intermediate developers get tripped up. It does not fill the available space. It fills the space that was reserved for it. And this is where we get into the algorithm, okay? The flex layout algorithm is also known as RenderFlex children have non-zero flex, but incoming height constraints are unbounded. I've never seen this error before in my life. All right. Don't be this guy. All right. The laptop losing the magic smoke. Okay. This is where, if you don't understand why we're having this talk at all, you're about to find out. Because we're going to take a good look at the documentation. If anyone has paracetamol, Tylenol, now's the time. All right, step 1. Lay out each child a null or zero flex factor, for example, those that are not expanded, with unbounded main axis constraints and the incoming cross-axis constraints. If the cross-axis alignment is cross-axis alignment stretch, instead, use tight cross-axis constraints that match the incoming max extent in the cross-axis. What? All right. Let's translate this into something a human can read. The first thing we're going to do is we're going to lay out all the children that have a set size in the main axis. They don't flex. They're set. 100, 150, 57.6. I don't care. It has to have a set size. However, we're not setting the main axis size actually yet. We're taking the children that have a set size and laying them out, but we're not setting their main axis size yet. This is what unbounded constraints mean. Okay, so now let's take a look at cross-axis alignment stretch. If cross-axis alignment is set to stretch, then force the children to be as big as possible in the cross-axis. That's all it means. So hopefully that's a little bit, it makes a little bit more sense. But notice, we still don't have the actual size set yet, even though there was a size set. That didn't come out right. Okay, anyway. Step 2. Divide the remaining main axis space among the children with non-zero flex factors, for example, those that are expanded, according to their flex factor. For example, a child with a flex factor of 2 will receive twice the amount of main axis space as a child with a flex factor of 1. Yeah. And people wonder why I need an asthma inhaler when I'm done with this. All right. We are going to reserve whatever space is left after calculating the things that have a set size. And we're going to divide it among the children that have a flex and that flex is not 0. I have no idea why that's there because I've never seen a flex with that was set to 0 in my life. Don't ask, I don't know. Anyhow, what we're also going to do is take a look at what if you like some children more than others, you know. Parents never play favorites. Okay, and you want to give some more space than others. The way that you do this is flex. Not flex. Flex. Okay. Now, let's take a look at here. I hate to break it to you, but math is involved. Thank you. Yeah. 3 children, 3 different flex factors, 1, 4, and 5. 1 plus 4 plus 5 is 10. There's your math. The first child has a flex of 1. The total flex is 10. This child gets 1/10 of the leftover space reserved for it. It does not get 1/10 of the space. The second child gets a reservation for 4 out of 10, so 40%. The last child gets half. Doesn't actually get it. It gets a dinner reservation. Big difference, especially later on. So then what we have to do is we have to calculate the DP. We calculate the actual number of the pixels that will be reserved for each one based on what their final share of the leftover space could be. All right, now what it is, could be. Next, we're going to get into step 3. Where's that inhaler? Lay out each of the remaining children with the same cross-axis constraints as in step 1, but instead of using unbounded main axis constraints, use main axis constraints based on the amount of space allocated in step 2. Children with FlexFit parameters that are FlexFit tight are given tight constraints, for example, forced to fill the allocated space, and children with flexible fit properties that are FlexFit loose are given loose constraints, for example, not required to fill the allocated space. You figuring out why we're here yet? All right. Let us ponder. We're pondering. Each child's main axis maximum size limit, the constraint, is set to the calculated number reserved for it in step 2. This is the max, not the actual size. So the maximum size that it can be is the size that was reserved for it. We have still not calculated the actual size. All right. So in order to get a little bit better of a handle around that, let's look at the FlexFit enum declaration. The child is forced to fill the available space if you use tight. Okay. The child can be at most that maximum that we set based on what was reserved for it. But it does not have to be. It can be smaller. Okay. Now, again, for more beginners, you have to say this, but it's only in the main axis. This has nothing at all to do with the cross-axis. We haven't even started with that yet. Yeah, here comes that paracetamol. All right. Let's take a look at the flexible constructor, okay? The flexible constructor, let's not even bother reading all that. What we really care about right now is the flexible has a default constructor with FlexFit loose, which means it's not going to force the child. The child could be smaller. Okay? Now let's take a look at the expanded. And actually, with this crowd, I'm going to go a little bit deeper into this. As you know, this is the constructor. We are passing this, okay, to the flexible. Now, the reason that's significant is when we get into the expanded, it extends the flexible, which means it has all the properties of the flexible unless we change something. But wait, there's more. What we're going to do here is in the super call to the flexible, we are going to set the fit hard-coded to tight. You cannot change it. All right? So the expanded is always going to be FlexFit tight. That's how it works. What if you want it loose? Use a flexible. Not that hard. Okay, so I'm going to blow through this because I do explanations about what a super call is to more beginners. Okay, it extends a flexible. You know, blah, blah, blah. Okay. Again, we're back to the default there. So let's take another look at that enum declaration. Okay, as we said, tight forces, loose does not. Like that. Now remember, this is using available space. What is the space available to each one? The space that was reserved for it. It is not, the available space is not the total leftover space in your row or column. That's very important to remember. All right, step 4. The cross-axis extent of the flex is the maximum cross-axis extent of the children, which will always satisfy the incoming constraints. Okay, I didn't need a big breath for that one. Although, when I was looking at this, I was beating my head on the desk for a little while because I didn't understand all the terms at that time. But I have this wonderful neighbor, and she has helped me so much. I would never have been able to understand this documentation, without her. I'd like you to meet, the amazing Wanda. Okay, so the amazing Wanda consulted the tarot, and she told me this, that the cross-axis extent of a rower column is going to be as big as the biggest child in the cross-axis direction. So it's going to make the entire rower column, a row as wide as the biggest child. And then the other limitation, of course, is if the parent has placed constraints on the rower column. This is not that hard to understand when you translate it into something a human being can read. So, all right. Now, what if one of the children wants to be infinite in the cross-axis and the parent didn't give it a constraint? Well, box constraints forth infinite height or width. We've all seen that one. But the interesting thing with that is it doesn't say cross-axis. I kind of wish it did, because that would help us know exactly what to go after. All right, step 5. Here we go again. Maybe I need a breath this time. The main axis extent of the flex is determined by the main axis size property. If the main axis size property is main axis size max, then the max axis extent of the flex is the max extent of the incoming main axis constraints. If the main axis size property is main axis min, then the main axis extent of the flex is the sum of the main flex is the sum of the main axis extents of the children subject to incoming constraints. I had no chance of doing that in one breath. But if you really think about what that documentation said, there is a normal human reaction. Yeah. Let's take this one step at a time here. All right. The main axis extent size of the flex is determined by the main axis size property. Yeah, no kidding. Why didn't I just say that? If the main axis size property is set to max, then it's going to be as big as the constraints coming from the parent. So to translate that a bit more into human, if it's set to max, which is the default, the length of the main axis of your flex is going to be as big as the parent is going to allow. Why didn't I just say that? For box constraints max height for a column, and for box constraints max width for a row. Let's take a look at main axis size min. If the main axis size property is main axis size min, then the main axis extent size of the flexible is the sum of the main axis extents of the children. What? In human. Just add up all the sizes of the children in the main axis and use that. Was it really that hard? Wait. Subject to incoming constraints. What in the world does subject to incoming constraints means? What does it mean without an S? If it fits. If it fits. Why didn't I just say that? All right. Step 6. How many of you have seen the Twilight Zone movie? Want to see something really scary? All right. Available space means the space reserved for it, right? Like that. Now, my speaker notes are off. All right, let's say the parent is saying the max constraints are 900. All right. Now, the first child is 300. And if I remember correctly, in this one, it is, okay, no, I'm sorry, this one is a set size. So the next one is an expanded. It had 150, I'm sorry, it is 150. So you have an expanded with a size box in it, and you have set the height of the size box to 150. Okay? Then we have another child, it's a flexible, also set to 150. Now remember, these both did not have the flex value set. Because they didn't have the flex value set, they had 50-50 reserved for them. So we have something with non-zero, I'm sorry, we have something with zero flex on top. And then we had two things with equal flex allowed to split what was left. Well, what was left was 600. So what we had reserved for each one of these was 300. How big's your column going to be? No, I really mean it. How big is your column going to be? Anybody? Somebody? Where's like an experienced Flutter engineer? Felix? Okay. How big is the column going to be? He says 900. Anybody else? 750. I guess those are the only two choices, right? Here's the goofy thing, okay? There's 150 of empty space. Nada. Not squat. But here's the goofy part of this, all right? Flexes don't have borders. So when you're looking at this, all you see is this. And you say, why is my column short? It's not. It's actually the right size. It's just the problem is not only do they not have borders, they're transparent. So you're seeing whatever's behind it. And without a border, it looks like it's short. So if you put a flexible and an expanded in the same flex, what's going to happen, quite possibly, is the flex will not use all the space reserved for it, and it's going to look like your rower column is short, but it's really not. So everybody give a big round of applause to Felix for getting it right. Now we know why BMW and Eric hired him. All right. Let's take a look at step 6. Determine the position for each child according to the main axis and the main axis alignment and the cross axis alignment. For example, if the main axis alignment is main axis alignment space between any main axis space that has not been allocated to children is divided evenly and placed between the children. All right. Let's take a look at our main axis alignment options. Okay. What we've got here is start, center, and end, then space between, space around, and space evenly. Start, center, and end, pretty self-explanatory. I mean, you know, there's not a whole lot here. So either they're aligned center or they're on one end or the other. They're pretty even. So let's take a look at with space around. Okay, I'm sorry, notes are wrong again. This is space between. What we're going to be doing here is we take all of the space that's not being used, we put this one on the very end, and we put this one on the very end. And then all the space that's not being used is evenly divided for space between. Now with space around, it's a little bit differently. done differently. The first and last are padded by half the amount that's between the rest of the others. What? Space evenly, in order to get that to work, the best way to look at it is this. If you were to put another half here and on the other end, it's not going to look right. So in order to make the even spacing look right, you do a half here, a half, a half, a half, a half, and another half on the end. And that is what makes it come out looking right with that one. So an easier way to see that is this. Even. They're all the same, right? Every single one is the same. Every single one has half on either side. That's how you end up with only half on the ends. So now let's really take a look at evenly. We're going to do the same exact space before and after every child. Okay? This is the one where you get the same amount on the ends that you get in between. So there's a little bit of a difference there, and you want to remember which is which, or just try which is which and see what works best. That's what I do. All right, so let's take a look at cross-axis alignment. This is the one that can hurt you. It can hurt your head. Of course, we have start, center, and end. Start, center, and end with cross-axis, actually also and with main axis of a row, and cross-axis, main axis, of a row, and cross-axis of a column. Most people think of it that start is to the left and end is to the right. Wrong. That's not the way it works. Start is at the beginning of the line in the direction of the language that the user has selected, which means start is on the left in most languages. However, it is on the right in Arabic. Okay, Arabic is written the other way. So if you are releasing in the Arab world, you've got to keep that in mind. So your start and your end are flipped in a right to left language. Now, stretch. It's going to try to force, okay, let me go back for a second. Do you remember when we said the cross-axis extent size is going to be as big as the largest child in that direction? Lie. Okay, because if you set it to stretch, and I believe the docs did say, unless you set it to stretch, when you set it to stretch, it's going to force all of the children to be as big as the biggest child, or as big as the parent will allow, and it's going to take the max of those. So let's see here. Baseline. Here come the next two fun ones. Baseline, in the cross-axis, we're going to take a look at a row. And what that basically means is we're going to take a look at putting the bottoms on the baseline. So if this is a row, everything's going to be lined up along the bottom. And we can take a look at the constraints that are coming in from the parent. Okay, here's the minimum constraints. Here's the maximum constraints. So baseline will not force to be maxed the way that a stretch will. But here's an interesting twist. What if the biggest child is smaller than the minimum constraint? And this is where it'll start to be painful, because it's going to lift it up off the bottom. You see where the min is? Over here on the left. The row is going to have to be minimum this height. since it's not stretch, it's not going to change the size of the children. So what it does is it takes the end of the biggest child, slaps it at the minimum line, and then creates a baseline underneath all the others, which leaves them hanging in the air. Try it, it's not fun. Okay, so as we were saying, this will shift up, and in big red letters, max headroom, the baseline does not touch the start side of the cross axis anymore. One more time. And that is for if you wanted to put it down low, what would you use? What would you use? Oh, come on, we've already covered this. Oh, end, you think? So, remember, we're not touching the start side anymore. Right? So if we want to bring everything down here, we don't want to use the end because the end's at the top. Okay, so what we're going to want to use is we're going to use start. Okay, but start already exists. It already aligns to start. All right. Baseline lets you float your baseline. Okay. Why? I don't know. I got nothing. I have no idea why you would want to use this. I don't know what use case, but you know, you could. It's kind of like Jurassic Park. You were so worried that you could that you didn't bother to think if you should. All right. So let's see if things make sense now. A flex is flexible, but don't confuse the fact that it can be flexible with an actual flexible. A flex fit has nothing to do with the fit of the flex. Flexes don't fit. The flex of a flexible determines the strength of the flexible, except when it doesn't. When doesn't the flex matter? When doesn't it determine the strength? Loose. Because it's not forcing it to obey the size. Okay. You can set the flex to 99 kajillion. If it is loose, it's going to be ignored. The flex fit of the flit determines if the flex of the flexible will be allowed to flex the flexible so that it fits into the better of the flex. Okay, boy, I'm losing speed here. Remember, if the fit is tight, it will allow the flex of the flexible to flex the flexible so that it fits better into the flex. But if the fit is loose, it's not going to do anything. So the flex fit determines if the flex of that flexible is going to be allowed to flex the flexible so that it will fit better into your flex, which is your row or column. Okay? And remember, don't confuse the flex with the flex, or you're going to end up all right. If you're as confused as I am after that, there are places you can get help. Let's see if these are current. The Flutter Dev Google group is a great place. I'm not sure if Eric still frequents that or not. He used to. Then we also have Reddit. It's Reddit. Don't always trust it. It's Reddit. You know, we like to say on Hump Day Q&A, this is YouTube, we have standards here. So the Flutter community on Medium, I counted last year, we had 1,200 articles. And these articles are from a lot of people like Felix, like Pooja Palmik, like Pawan. You know, I mean, they're written by people who know what they're doing. Then there is also the Flutter community page on Facebook, which has been badly neglecting, and it is totally my fault. I have to get on that. Twitter X, whatever they're calling it this week, is Flutter Dev. and then you can follow who that loser follows. You know, you can ignore me, but I follow some pretty cool people, which reminds me I've actually got to start following Phoenix. I don't know. I haven't got you yet, man. Then there is Hump Day Q&A. If you're not familiar with it, that is a live stream that we do every Wednesday. Simon Lightfoot, myself, Randall Schwartz, and Danielle Cox get on there and answer live questions for people in real time. And answering questions for a talk is easy because you're limited to that subject. Hump Day Q&A, we are open to all comers. We have no idea what people are going to ask about. 1 minute they might be asking about when to use a container versus when to use a sized box. They might be asking, why is it important to make things constant? And then all of a sudden they're asking for a very specific thing in the fine print of FFI. It'll give you whiplash. So the show is awesome, not just because I'm on it, but I mean, he knows there's almost no question Simon can't answer. He has been doing this for 30 years. The knowledge in the man's head is bizarre, but it's also very helpful. And with that, I'm out of slides. So fortunately, I'm done talking at 1,000,000 kilometers an hour.
Thanks a lot, Scott.
Yeah. Oops, yeah. All right, nobody has any questions, right? I covered everything thoroughly.
Can we get this mic on? Yes, it is on. Perfect. So for this Q&A, we actually have a little bit extra. The person that gives the best question will get a dash. So get into the link and write your questions, and remember to write your names too, so we can know who to give the dash. Anonymous is hard to find. But I have a question to start with. Like, some of this is pretty confusing stuff. Have you just like sat down and learned it or have you like organically learned it over all the years you have been active in the Flutter community?
It's a little bit of both. And the serious answer to that is I hadn't touched coding for 20 years when I started Flutter. And I had no idea what any of these terms meant, and that's a big part of the problem is beginners go to the docs to try and figure out what rows and columns do, and they get pointed at this. And they get thrown all these terms: FlexFit, flex, flexible, extent, constraints. Somebody who's brand new to Flutter in their first week is trying to look up how a row and column works. They run into this like a brick wall at 400 kilometers an hour. It's bad. As a beginner, I went through it. So after I finally wrapped my head around it, I realized what things meant, and I got very frustrated with why didn't they just say what it meant? And then I figured, there must be a lot of other people struggling with it too, so I'll put together a talk on it. And then I actually researched it properly in order to put together the talk. So it's a both and.
Yeah, that makes sense. I think like from when you begin with Flutter, everything seems so smooth and super easy. When you start building the apps, you're like, it's so fast. I think this is one of the first things that a lot of people run into actually as a big problem.
RenderFlex children have non-zero flex, but incoming height constraints are unbounded.
Yeah, exactly.
People have
like,
nightmares
what is this?
about that phrase. Yeah. And it's, no, but in all seriousness, I'm sitting there looking at that error going, what the heck is a RenderFlex? I'm using a row or column. I don't understand.
Yeah. Where did it come from?
Yeah.
Can't search my code for RenderFlex.
Yeah, I mean, you sit there and you do a right click, find in files, RenderFlex. You get nothing.
Yeah. All right, let's take some questions from the audience here.
I thought that was.
Isn't baseline related to the text baseline actually? Because text bottom is not text baseline, and it can avoid off by one pixel issues.
Yep, off by one. They say off by, that's my license plate at home, off by 1. No, but that is absolutely correct. Thank you.
That was a question from Matti. Then we have Tom that wishes to gain some more knowledge on this. And do you have a model or sheet with the human explanations that you could share?
A what?
A model or a sheet with the human explanations of what you have.
You know, a
presented.
handout would probably be a good thing for this talk, wouldn't it?
Yeah. Well, maybe later in the Slack. Who knows?
Yeah.
Why do we have expanded if it's just flexible with FlexFit tight from Joachim?
Why do we have spacer? You know why we have spacer? Because Scott got sick and tired of writing expanded sizebox.empty, expanded sizebox.empty. No, it's a convenience widget. That's all it is. If you were, you could use, you know, flexibles with tight and loose all day long. That's all the compiler is going to do anyway. What it does do, and what spacer also does, is when somebody's reading the code in a quick pass, I imagine all of us have the constructors in a different color than a lot of the other things, so you can read down and just see size box, column, size box again, colored box, text, and you can and you see exactly what's going on. But if you use a flexible and you change the parameter manually, then as you're skimming the code, you have to stop at every flexible and check the fit. Whereas if you're using an expanded, you can just keep blowing right through without even slowing down.
Oh, makes sense. Then we have a question from Red. How to align one widget in the top left of a stack and another widget in the bottom right, while keeping the stack as large as a third bigger widget that it contains? I think we need a little whiteboard here.
Actually, that's not that bad, because
Yep.
I know it's not proper to do, and people might argue against it, but for me personally, I get frustrated trying to use positioned because I don't want to put hard-coded numbers in anything anyway. I use a line. I literally use a line in a stack. So for me, my answer instantly would be, how do you want to align it top left? Use a line with alignment top left. Really. And making it as big as possible. What stack is stack fit? It's expand. Yeah, it's expand. There is a stack fit expand which will make it match the incoming max constraints. So you've got it as big as possible. If you want to align it somewhere, align it there. You know, and if you want to place it halfway off center, use alignment positive 0.5. You know, it makes my life a whole lot easier. I realize most people will use positioned. I know it was designed to use positioned, but you know, I tend to do things wrong anyway.
Good answer. And then we have a question from Moritz. Do you still just try randomly flex stuff until it looks right, like the rest of us do? I thought that was the official way.
Actually, very good, very good. I've got a shortcut for that. Always make sure that the total of all your flexes is 100, then you can just set it to a percentage and you're done. If it all adds up to a total of 100, then 25 is going to get 25%. So, and Simon always tells me, don't bother doing that, and I'm like, shut up. Not everybody has a mind like yours, Simon.
Very true. From Enoch, are there any performance considerations / issues when dealing with many flexible widgets?
Not that I'm aware of. And even if there are some, that gets back into, I think the garbage collector is a good way to look at that. Eric Seidel did a podcast on, what was it, Software Engineering Daily, where he went into the details of the garbage collector, somewhat, not to the point that it would drive you crazy. But in short, I can't remember if it's 50,000, 70,000, or 100,000 small objects per frame can be cleaned up. That's one of the reasons that we can get away with a list instead of having to use an array or other things like that. I mean, this garbage collector is nuts. So is there some inefficiency perhaps? Yeah, if you don't use it quite right. Have you taken a look at the processors on a modern phone? So is it inefficient? Oh yeah. Yeah, most of what we do is very inefficient. I mean, you know, people who write graphics code would have nightmares over the way we do things. But, you know, and people who are writing game code that have to try and squeeze out 120 FPS. In our case, it's not even going to slow us down. It's really not. A modern processor, and we're just trying to hit a minimum 60 FPS. Okay, you know, that garbage collector will pick up quite a bit. Okay.
We have a question from Sten Erik. What is the minimal kit of widget classes one needs to do most any layout? That's a very broad question.
The minimum, I would say, is first of all, understand the difference between container and sized box, and container and the things that go into it in order to make it do what it can do. And the reason that I say that is you can't make a container constant. And I can't remember which it is, but there's only one parameter that's preventing that. So if you don't need that parameter, you know, just go build what you're doing. Like if you're going to use a container to do, I don't know, padding and a color, what you can do instead is you can put, say, a sized box, and then you have a padding, and then you use a colored box inside the padding, and then you put whatever child in there that gets padded. You don't have to use a container. Next, understand what constant is doing. Then after that, size box, colored box, text, row, column, of course, stack, icons, buttons, you know. I mean, it's really, I mean, this is a minimum kit. I mean, we're not getting into slivers or anything like that. If you really need to scroll stuff because you're hitting the end of your page, just use a single child scroll view, and then you might have to give it something that will give it some constraints. But you can do a lot with just that. You really can. And maybe not asset image, and maybe even network image. Cache network image is a good thing too.
All right. Last questions. Last question, singular. Would you contribute some of your explanations to the Flutter docs website? The non-robots reading them would love that.
Actually, that is in progress. And Hixie, if you see this, I'm sorry. I'm under a deadline at work, and it's slowing me down again. I had put in a preliminary PR. I got some feedback from the team. I started doing the changes, and then life happened. So unfortunately, life is still happening. I am making a little bit of progress, a little bit at a time. We were having a conversation about that last night at dinner. Parts of this appear scattered all over the documentation. You can't just change it in one place. So someone was nice enough to mention that there's a macro for this that I have to look into. So it is coming slowly. I have a soft release on October 1st. The app I'm working on must be released by the World Series of American Baseball, or like I'm a dead man. But yeah, I will get to it as quick as I can.
Yeah,